Hello, students. Getting into 11.2, I had a few questions come in, so let's take a look at those. Question 2, and it says part K. So let's take a look at question 2, part K. Determine which of the following figures labeled can be classified under a given description. Okay, a kite. Well, opposite sides parallel, all sides congruent. Well, remember the definition of a kite. So go back if you need to find that definition of a kite. But what we've got here is a rhombus, and this rhombus is, by definition, a kite, meets the definition of a kite. So there we go. Adjacent sides are congruent. So that one's a kite. So remember now, if it's a square, that makes it a rhombus, which makes it a kite. So looks like 4 and 6 would match. Also kind of feels like 8 and 9 here would match the definition of a kite. And that's because you've got the two adjacent sides that are congruent. And so we've got the 2, 2, the 2, 2, and 1, 1, 1, 1. So it does look like those are congruent. And therefore, see what I'm saying? So this one here and the one underneath it right there, those two are congruent, and the two right up here are congruent. So one is just convex and one's concave. So don't let that stop you. Kite does not mean convex or concave. It means does it meet the definition. So anyway, there we go. That's 2K. Okay. All right, let's see here. 13L. Okay, let's take a look. Oop, can get that out of the way. We'll move over to page here. Question 13. How many lines of symmetry exist for each of the following? That's weird. She said 13L? 13L. Okay. I don't see 13L. I feel like I'm in the right place. Am I on A? Let me take a look. No, I'm in 11.2B. So I feel like 13. Yeah, I'm not sure then which one. But in general, like to say, if you had a line, then how many lines of symmetry exist? And I would say, here, let's jump in here and do just a quick whiteboard piece. So what would that look like? Well, okay, let's see here. So if I draw, oops, I wonder if I can draw a straight line. There we go. Picture this going on and on forever in both directions. Let me see here if I can get some thickness. Okay, so that's a pretty thick line there. And then think about it. So a line of symmetry would be one that you use to, wherever you draw this, it should make a perfect reflection over itself. So if I draw a line like this, the line I just drew is a line of symmetry because as I cut it, both sides look exactly the same. They both look like a ray going off in each direction. And then if you, oh, I don't want to, can I just grab one piece of that? Why do I have to grab both? Whatever. Okay, there we go. All right, so but you can also move the line anywhere. I can move the line over here. I can move the line over here. I can move the line over here. Anywhere I go, you might be thinking, oh, but this side is short and stubby. Well, it's just the representation. The line goes on forever. So a line has infinitely many lines of symmetry that are perpendicular, but you'll also have one additional line of symmetry, which would be, okay, let's see. Let me change color. There we go, which would be right here. And let me change the width just so you can kind of see it. There we go. Okay, so right there. So think about this blue line. Maybe I'll change the colors. Does that help a little bit? If it's a different, I guess it helps in the middle on the black, but it doesn't help everywhere else. But yeah, this other one would also cut it perfectly, right? Cuts the plane mirrors over itself. You can't tell. So yeah, you've got infinitely many. You also have some rotational symmetries because you can rotate it through any point on the line 180 degrees. So point symmetry through every point if you're asking about just a line. Okay. All right, let's get back to this. Okay, let's see here. Next question. So again, if I misunderstood that, it said 13L. I'm not sure, or maybe it's capital I. I can't tell. But there you go. Yeah. So